So anyway, I'm here to talk about the journey. You know, for me personally, this journey started when I was the CTO at Cisco, right? You know, I just sold aerospace to Cisco, but I was working with some very large enterprise customers, and what they were starting to tell me was, Bob, we're tired of controllers crashing. We want to get, we want to move faster, right? They were tired of releases every year, and they wanted visibility. It wasn't about, taking care of the access point, the switch or the router. It's about whether or not, if they were going to put an app, on the device for their customers, whether or not that customer is going to have a good experience. And so that's where the Mist AI journey started. And for me, one of the inspirations was really around Watson, right? When I saw Watson play Jeopardy, I don't know if you guys remember Watson playing Jeopardy. I was like, okay, guys, if they can build something that can play Jeopardy, we can build something that can actually answer questions on par with network domain experts, right? And if you look at that journey starts with data, right? What became obvious, the reasons that, Susie and I decided to build an access point at Mist, it wasn't because we thought the market needed another access point. It was because that access point was a source of data to answer the question of why is a user having a poor internet experience? So when you want to answer that question, that's where you want to start the data journey. If you look at where we've gone, where we started, right? We started that journey with the access point. As we've gotten into Juniper now, we're now starting to ingest data from the entire enterprise portfolio, right? We moved from access point to switch, and now we're moving to the SD-WAN router. And what that really means as we start to ingest more data, from that client to cloud, we're starting to answer more questions with more granularity, right? When I pull that access point into there, that let me answer all types of questions about your connectivity experience. And when you look at that access point, compared to what I did 20 years ago at aerospace, when we're really just monitoring, helping enterprises take care of devices, the paradigm has moved to this user experience, right? In this journey, it's not about helping people manage a switch or a router. It's about trying to help them manage that in-state user. And that really requires user state data. So back in aerospace, that was all about sending data back every minute or something, synchronously, right? Trying to keep track of that AP out there at the end of the thing. This time around, we're also keep bringing back asynchronous user state information, right? We're starting to keep track of exactly what is that user state at any time asynchronous. So if your state changes, data comes back from the access point back to the network. And we're starting to extend that now into the SDN router, right? So that router is what lets us start to answer questions like, why are you having a bad Zoom experience or a bad Teams experience, right? Because that router has all the session information you need. And when you see with the data, what we're doing now, we're starting to expand into third party, right? We went across the Juniper portfolio. Now you're going to see us start expanding into the data center and into third party things like Cradlepoint, right? If I need to answer questions about the 5G backhaul, I need to get data from that Cradlepoint device. If I want to start asking questions about the services, I need to get information from like Down Detector, from services that keep track of the cloud. So you're going to start to see it continues to ingest data from the data side. The second piece of the puzzle, and this is what was most interesting on the journey, this adventure, was getting data back to the cloud. AI can't even start until you actually get data back into the cloud. And that was probably what we did for the first year, was just figuring out what data. And what we found were customers really appreciate that, getting that data back into this SLE framework, right? So I had to get this data into a format that could actually apply some data science model to, right? It turns out that the same data that Marvis needs is the same data that your IT person wants to look at, right? Because it's in a nice structured format that's actually logical and everything. And so that's what we found on the journey, is just doing that. Customers saw tons of values because they didn't have to log into devices anymore. The data they needed was actually right there at their fingertips in the cloud. So that was the second pillar of this primitive, right? Getting that data into a format that we're going to apply some LSTM model or some boosted tree model to. Probably the third thing is the data science toolbox. Now, we all have access to the same algorithms, in terms of boosted tree, LSTM, all these deep learning models. Those models are all common across the industry right now. What is different is the skill set and making sure you actually have the data science that can do something with it, right? And that's probably where we differentiate more, is we've been doing this since 2014. So I think we've been on the track longer than anyone else there. Is actually building a data science muscle that actually uses these models to do something interesting. And finally, the conversational interface. This is another key pillar. You know, when I was at MIST, there's a lot of argument between, you know, what people really use this stuff and everything. But this really goes to how do you gain trust? You know, when we actually tried to start bringing Marvis into an IT department, it's like any person, right? You know, if you know your natural, most IT people don't trust whether it's an AI person or a real person. Most IT person are not going to trust anyone to touch the knobs on their network, right? You got to earn that trust. And that was the old concept around the conversational interface. You need to have these AI assistants start to look and feel like a real part of the team. And it's got to be a much better way of actually getting data out of these systems, right? Because we went kind of from the CLI paradigm, you know, we're all doing CLIs, and we kind of went to this dashboard phase of things. The problem, these networks have gotten so complicated right now. Even the dashboards are overwhelming, right? You're going through all these dashboards trying to find the dashboard that's going to solve your problem. Conversational interface starts to give you a much better way to search for what you're looking for in your data and get you to that starting point. And this finally all leads into ultimately, are we going to get to that self-driving thing? And we're going to talk a little bit about this. I would tell you, we are starting to see actual first signs of actually some sort of semblance of an AI assistant helping IT departments offload simple tasks, right? Bad cables probably our best example of, you know, people are starting to get to the point where they actually trust the algorithm for finding bad cables. They start to let Marvis actually start issuing the ServiceNow tickets on their behalf, right? So that's the ultimate form of automation. And when you look at AI, AI is really just automation taken to the limit, right? Because here we're actually doing something on par with a human. So we've been doing automation for years. We're just taking it to the ultimate goal that we've been trying to get to for most of our careers. This is the data science toolbox. And what this highlights is really, you know, and I try to explain to people, it's like you look at these self-driving cars, it's just not one algorithm, right? There is a variety of algorithms under the hood to get something to do something on par with a human. You know, and that's the big difference between AI and ML, right? ML we've been doing for what, 20, we all have done regression algorithms probably early in our careers. So that has been around for a long, long time. What has not been around is really doing things on par with humans. And that was really because in 2014, we started to see these deep learning models come out. These are models that have billions of parameters. It's just when you look what's going on now in these deep learning models, it's amazing how much data we're using, right? And AWS and all the cloud stuff, you know, I don't have to worry about 20 years ago, I was trying to put all this on a Linux box, right? And there's only so much you can put on a 1U Linux box. You know, with AWS, the only problem we have is our bill now. There is no limit to compute and storage, except for how much I have to pay AWS or Google for all the cloud storage. So the point of this is when you look under the hood, this is the stuff you want to be looking for. These are the algorithms that are actually making a difference and actually making this on par with humans.
So I got a question about that. Are these technologies that you're using right now in the product today?
Yeah.
Or are they being just kind of explored and experimented?
No, these are like real projects. Like, you know, if you look in here, RM and Julie will go deeper in this. We've been doing this for a long time, but there's actually reinforcement learning. So the big difference is 20 years ago, we were trying to optimize how APs see each other, power levels. Now with reinforcement learning, we're actually optimizing the user experience, right? So we're actually looking at both the user experience and AP, and you're basically optimizing all the power and channels to make sure that you keep everything symmetrical. You know, so that's that game. This is the gaming theory, right? This is all used. This is what you see in Go. This is what they use for all those games and type of stuff. This is probably the biggest thing. If you dig into this all this transformer based. This came out in 2017. It's something that Google came up with. You know, all that, you know, Alexa, Siri stuff. And, you know, but that stuff has gotten better, right? And that's better because they're using what they call transformer based techniques there. So these are XG boost. This is throughput prediction. Like if you want to predict someone's internet throughput, that's not a black box problem. You've got to use some sort of tree algorithm or something that you can explain why, if you're going to predict low throughput, you know, why you're predicting low throughput. Yeah, so these are all these algorithms. So this is the algorithm. This is the customer facing aspect. This is how it shows up in the product. That makes sense?
A little bit. I mean, as you go through the product demonstration, it'd be really interesting to see, like, point at a feature and like, hey, in this feature, we started using
Yep.
this algorithm, we applied this technology, and this is how we got out of it. Because a lot of times, we hear these terms and making it real as it's applied to the practitioner, I think is really helpful in these types of, presentations.
Yeah. So I've been trying, I'm a big data science person. So this is like the magic behind it. And if you look here, this is all the stuff that's been around for years, like 50, 100. I mean, this stuff here has been around for a long time. What's relatively new is this deep learning stuff. This is what came out around 2014. This is what kind of got us to that inflection point that has made AI more actually feasible and real.
So, additional question along the lines of the hero stats from the previous session about how much Juniper has grown in revenue and correlating that to the past couple of years where, companies like CVS has 90,000 remote workers now, and just the sheer amount of data that we've gotten out of the work from home. How has that either provided additional insight or changed your approach to how you analyze this data and answer some of these more complex questions?
Yeah, so I mean, I think what I see happening out there, since 20 years ago I did aerospace, the big dynamic that's changing in the market right now is networks are becoming distributed, right? 20, 30 years ago, everything lived in the enterprise data center. All these apps were being maintained by some IT department. Those apps are all gone. Those apps are distributed across multiple data centers, public, private. They may, some of these companies may have 2 or 3 data centers where they're running workflows type of thing. So that's got a lot more complicated keeping track of where all these applications are working. Now, from a data point of view, this AI ops that sits on top, that's the new thing, right? We have much more complex networks where from the user to where the workflow is, because the user is not even at work anymore, right? I mean, probably none of you guys go to an office, right? You're working from wherever your coffee shop is. You pull your laptop up and you start working. So I think that answers your question. That's kind of the change of the data. It's becoming more about cloud, and probably the 2 big architectural change is cloud and AI. Cloud is the major, that was kind of like Meraki and that whole thing. We saw that happen. And then AI is the new architectural change.
Yeah, so I guess the question.
So just one more to add to that, right? To your point of the world went from corporate offices to everybody working out of home.
Mm-hmm.
For us, that's like just what was 100 branch, 1,000 branch now became a 10,000 branch, 20,000 branch situation, right?
Exactly.
And that is what actually led to the whole WAN assurance element that we'll be going into deeper. That telemetry became very critical because now it was not just a known wired wireless network in the control of network IT. You were dealing with multiple ISPs, with multiple, for lack of a better word, crappy WAN links or issues, whether it's DNS, ARP, etc., that are ISP dependent. And that is where, to your point of, hey, did you look at other data models? How did that sort of change our viewpoint of how AOps could help? That's where the WAN assurance piece came in and became even more critical in this distributed world.
Yeah, well, real practical, but I had to call my SP last week. I moved and mice have been eating that. Literally, mice ate away my connectivity. My business partner at home is like, hey, why isn't Wi-Fi working?
Exactly.
So
Wi-Fi is the blame.
Wi-Fi working? And it's, she's plugging up additional meshes to try and boost the signal. You're making it worse. So, practical stuff are what we're dealing with in the field. I'll love to see in the demo, how does Marvis help? Why does Keith Wi-Fi not work?
Well, I would say bad cable is probably the most appreciated model we have right now, because it's amazing how many things are due to a bad cable thing,
And Bob, in this case, it could also be the bad WAN link that Marvis will help with. Yeah.
But to your point, that's why things have gotten much more complicated. There's much more between you and the actual where you're trying to get to. There's a lot more cables, wires, and boxes between whatever you're trying to get done. I would also say, if you look at, why did I leave Cisco to start a wireless company, which everyone thought was crazy? It was based on the premise of cloud and AI, that those are fundamentally this is architectural changes that were easier done with a blank sheet of paper. Because when you want to do, when you want to process data real time, you have to have a cloud that can actually process data real time. That means you have to have pipelines in place to do that in real time. And that's a big change that's a big architecture change. And then AI is, more importantly than architecturally, is organizationally. So this is the other subtle thing that happened at Mist on the journey. Yes, I had to go build a whole cloud, Kafka, Storm, Flink, all these real-time pipelines for processing data. But organizationally, the way this works right now is as we move everything into the cloud, it turns out that our customer success, our customer, and our data science all have access to the same data now. It turns out that once you move to the cloud, the customer success is a proxy for your big customers. You know, our customer success team has the same data that our big retail customers have, right? They all see the same thing. So this is what's changing the models organizationally at Mist. I got my data science team sitting right next to my customer success team. They meet every week. That will not happen at Cisco or Aruba. I mean, if you go Cisco, you're going to find the data science team is over in building 10 and, you know, the wireless team is over in building 23 or something weird. So this is the other big thing I try to emphasize to people is organizationally, cloud and AI changes how you have to organize your company. You know, whether it's us or you or whatever, you need to make sure you get your data scientists next to your data domain experts, right? These guys know what they're doing mathematically, but they have no clue about networking usually. These guys are the guys who actually know what's going on inside the networking domain.
Question for you. Jumping back to kind of the previous slide, you had the throughput prediction on there. When you start looking at the AI, how much of this is moving from kind of the reactive? Like you've got root cause analysis there. How much of this is something went bad and we've collected this data, or something is going bad versus this set of conditions is happening? Not bad yet, but we think it will be soon. How much are we getting to a kind of a proactive, almost predictive point yet, or is this still very, very quick reaction?
I would say from a practical point, we're not predicting months in the future. I mean, I think we're predicting, a lot of this predictions is in the hours. You know, we can predict, you know, where capacity or throughput is going to be in an hour. It's kind of like weather, right? You know, we got pretty good at weather, right? It's amazing how good we are hourly. But you look at those hourly predictions, we got pretty good at predicting where that we're going to get rain the next couple of hours. So same kind of theory. We're getting better at predicting on the hourly. As you get out in the farther week, chaos theory starts to kick in.
So just kind of going back to what Keith was talking about there, when we're talking about his home, that's home users are a very different use than enterprise users.
Correct.
And I'm going to go like into a real specific into warehouses. I've worked in a lot of warehouses and they're RF nightmares. So I don't know, maybe this might be a better question when we get into the demo side, but how are you able to differentiate between Keith's rat problem and my warehouse stack filled with copper cable?
You've obviously gotten terminology from my wife. Field mice are to her right rats, but
In the home problem, you know, right now we're not trying to solve the consumer or service provider problem. Although we do have on the enterprise side, you know, we send people home with enterprise APs, which address kind of his problem of being able to bring that enterprise experience into the home. You know, in your warehouse, I would tell you, we have some of the largest retailers right now, you know, and they're running their robots on this. And yes, and they're very, I mean, they respond, I would tell you, the big retailer who runs a robot on our Wi-Fi, you know, it's a race between who, if that goes down, whether we find it first or they find it first, because it's within minutes. It does not take long for them to report a problem.
And the baselines are different, right? So Keith's home network baseline and the peers that we see there and the client experience we see there will be very different from a warehouse baseline, where you have different type of client sets and different APs, and the whole environment is much different. And so we operate on a local baseline versus a global baseline.
Yeah. So anyway, the point of this one is, hey, you know, once you got to build these real-time pipelines, then you, organizationally, you got to tie your data science into your domain, which is your customer success. You know, and my claim is, right now, Mist Juniper, we are the only ones who are currently using our actual AI ops in our customer success. I mean, we are eating our dog food. Every week, the data science team, the customer success team gets together. They review what support tickets that Marvis could answer. And then we basically work on the ones that they couldn't answer.
Yeah, so I mean, just practically speaking, like give me a story of like a time when they had an aha moment where the machine learning algorithms came up with something that was unexpected by the team that, because I'm still trying to wrap my head around how does the ML get turned into something that wasn't originally programmed, meaning can it find something that's quote bad, even though nobody told the system what good or bad is?
Mutual information. So mutual information, it's not really a deep learning. Mutual information is a data mining technique, but it lets you basically associate one random variable with another set of random variables, right? Basically saying if this random variable fails, which random variable most likely predicts that failure? So this is what all the SLE metrics are set up to do, right? So we have SLE metrics that are basically tracking every user's pre-connection status, right? So if there is a timed connect, right? If all of a sudden we see a bunch of connection failures coming in, now I got to figure out what is causing this connection failure. Right now, this happened in a big warehouse situation where they had this weird problem. They could not figure out what the heck it was. You know, they kept having all these subtle, you know, kind of coming and going complaints of these devices. It turned out with mutual information, we were able to sort it out to get down to, hey guys, it's associated to this Zebra handset running this particular version of code, right? Those are the needle in the haystack problems if you're trying to sort out something that flaky problem and you want to use math to sort it out. I mean, so mutual information is probably the best example of how do I take 50 network features and sort it out. The other good example is what we quickly figured out is Apple released a bug in one of their releases, right? Any captive portal page that had a, you know, one of those agreements longer than a megabyte would break. And so that showed up immediately across all the systems, right? It's like, hey guys, we have a common problem going across all these customers. You know, it's getting correlated to Apple iOS 12 or whatever it was during that release. Does that make sense how this stuff started?
Yeah, I mean, it's starting to kind of break the surface of what these.
I'll give you another example, and this was early on in our journey. We were deploying at a large retailer, 2,400 locations, 24,000 APs. But before we went into that, they gave us, you know, they had a really tough time with the current incumbent Wi-Fi network, and they were getting point of sale issues and guest access issues that they just had no idea how to troubleshoot. So we went up there, we talked about, hey, how we collect data, how we give visibility, how we give actionable insights. They said, sure, July 4th weekend is coming up. I'm going to give you 6 of my toughest locations. Show me what you can do, right? Because it can't get any worse than it already is. We're like, great. At that point in time, we were wireless only. We were not acquired by Juniper. We had no wire telemetry, no WAN telemetry. We put in the network 10 p.m. on July 2nd. July 3rd, network turns on, associates are coming in, point of sale devices start connecting, you can see clients on guest Wi-Fi. But we are seeing for a certain set of devices, our successful connect service level expectation is dipping. It wasn't across all devices, certain set of devices. So we actually called them and said, hey, Marvis is telling us there is a problem, and we could very clearly see it's not DHCP, it's not authorization, but there's something on the internet, right? And we could already say that. So we called them and said, are your store managers complaining? Are your store associates complaining? Because we are seeing certain iPods being used for point of sale, not being able to connect effectively. And some of them are not connecting at all. Like, no, your ML is all wrong. Go check your math. We're good. We're like, fine. Come peak traffic, July 3rd, 4 p.m. We get a call. Missed. What did you do? Devices are not connecting. I can't run transactions. We're like, hold on. Let's go into the portal. We're already saying something on the internet that's causing your issues on a certain set of devices. Did you change something on your WAN side? They're like, yep, we have Viptela routers. We did a firmware upgrade. Great. Did something change there? Because we're seeing certificates failing to go through sometimes. Yep, the default value for the MTU had changed. The jumbo phones were not able to go through. So to your point of, did we train the model to go look for MTU mismatches on the internet that will impact devices? No, we did not. We were looking at successful connects for the devices on the wireless network. But we did have, as Bob said, mutual correlation. We had internet as a variable that, hey, anything on the WAN, it should capture it here. And that's how what would have been a 2,000 store outage for them because they were rolling out that firmware upgrade across the chain in the next coming week, we were able to preempt that and they were able to get a fix to get that issue resolved.
I know.
So
So I think one of the senses I'm getting here is, to Gerald's point, what kind of assistant is Marvis? Is Marvis a, hey, can you tell me what's going on assistant, or is Marvis a, hey, here's what is going on assistant?
There's two aspects to Marvis. One is troubleshooting for people who are trying to troubleshoot problems. The other thing is Marvis actions for people who are trying to automate. So think troubleshoot, operations. So right now we're trying to build an assistant that can basically troubleshoot and manage networks on par with human IT experts. And so this is the action piece of it when we get into actually,
Yeah, I mean, but in her story, and this is exactly the point that I'm trying to get to, is Mist didn't say there's an MTU problem, right?
but on the wireless world only. But now what we'll show you is now Mist will tell you, hey, Mr. Customer, because we have telemetry coming from the WAN as well, there's an MTU problem before the call even comes in.
Right, right. That's what I was kind of getting
Yeah.
at. It's like before, my guess is you can say, I have situational awareness to the problem being over here somewhere, but I can't tell you what it is because I don't have the analytics, the measurements, the metrics to do that. But if your system could now say, well, I have seen events that this router had been upgraded, and I've seen, TACAC's accounting record that said this configuration happened. Are you then saying that your system could then say specifically, Keith changed the MTU on this date, and this is with a 98% probability the reason
Yes.
why this is happening?
yeah. So this,
Not only that, I will open up a ticket for you in ServiceNow saying, hey, you have an MTU mismatch problem on these routers on these sites.
Yeah.
So that's something you can do today.
That is
Yes.
what we can do today.
and so this is event to your configuration, right? So, I mean, so there's a graph, right? That has, and this is kind of the abstract thing, right? There's tens of thousands of events coming in here, right? And I think Jinsing told me yesterday, it's like 300, 600 terabytes of data come in to the back end every day. That's got to be correlated down to some action that an IT guy cares about. And you think about an IT person, right? I mean, they do this automatically all day, right? When something stops working, they start going through all the events, trying to figure out which series of events has caused a problem. Probably the best example is we were at a big retailer in a demo. Our demo wasn't working. They're like, well, guys, Meraki worked, you guys didn't work, sorry. It turned out that someone had changed the configuration on a router and changed the MTU size, so we couldn't get the authentication packets through, right? So that's the thing that this solves, right? Config change happened way over here. They swore it never changed. They swore, hey, no one touched that thing. Sure enough, someone had touched the router MTU that basically prevented things from authenticating onto the network.
The final question on that then, are you saying that this system does in fact take in like TACAC's accounting records?
We do not take in attack accounting records yet, but we're starting to take in config changes now. So that gets back to the ingestion data strategy right now. Right now, we're ingesting data from APs, switches, and routers. And now we're starting to ingest data from third-party sources. So as we ingest more data, what that gets to is better granularity, right? I can tell you the problems in the data center, but until I get data from the data center, I can't tell you what server's causing it. I know the problem somewhere there.
I'm anxious to see at some point an integration between Apstra and this, because this stuff is getting harder and harder. It's supposed to get easier, but it's not. And to be able to correlate this much data, especially when the lines between data center and edge are being blurred, the need is substantial.
So that's my mission. I mean,
That's the journey.
so if you saw my new title at Juniper now is Chief AI Officer, which is really Chief Data Officer, right? It's questions, how do we get data ingested? I spent the last 3 years at Juniper basically getting Marvis to ingest data across the enterprise portfolio. The next mission is now to across the businesses, right? Data center is probably the next stop because you want to track that problem down. Usually it's a point of sale or something went wrong in the data center that they've got problems now.